All right, so you guys are learning how to handle rational equations. What does rational even mean? Rational means can be written as a fraction. So when you're talking about these equations, you're talking about fraction equations. So you got to fix that because fractions aren't so nice. So yesterday, some of you guys are not paying attention. I need you to pay attention. That means usually implies looking at least one of your eyeballs up in this direction. Okay, I can tell that chair is not going to work. Sit in the normal chair, and then you can look in the right direction. All right, so if I have a over 3 plus a minus, no, let's say equals 7, what would I multiply by here? 3, because I want to fix that fraction problem, right? What would I multiply by now? X. What would I multiply by now? X times x plus 1. And the only thing we're going to add today is add one more layer of complexity. What if this one's also got a fraction, and it's not necessarily something different? It's this. How is that not different? All right, so when I multiply by x times x plus 1, do you get how that will fix this x problem? And when I multiply by x times x plus 1, do you get how that'll fix that problem? And when I multiply by x times x plus 1, do you get how that and that are exactly the same as each other? So that's the only new step. That's it. Okay, so you just have another thing to cancel, that's all. It's no big deal. All right, so you have a bunch of problems that are going to be like that. So let's do one together to make sure you really get what I was just saying there. Let's say you had x over x plus 2 plus 3 over x equals 4 over x squared plus 2x. See if you can multiply by the right thing. Leave yourself plenty of space. And I want you to think about these as problems that are like the ones you can impress your friends and family with. Like, holy crap, look at how this problem takes up a whole page. Because they do. They just take up so much room and there's so much canceling. And then there's grouping terms together, and then you get this quadratic. So like you've spent 5 minutes in the problem and you finally got it to a quadratic. And then you got to solve a quadratic, which you need to use the quadratic formula for. So the point is why this class is so much harder than last year is because it takes you like 5 minutes just to make it into an easy enough problem that it would have been like problem like from last year. Last year we would have just given you the quadratic and said solve it. Now we make you through it take 10,000 steps, and then you finally get a quadratic, and then you have to solve it. So that there's so many steps. You mess up one, you don't get the credit. Another thing I want to talk about in a problem like this is how they score in the AP tests. Many of you are heading towards the AP Calc. You don't have to do the AP version. You can do regular Calc if you want to. But if you are interested in trying AP Calc, it would have, the way they score it is kind of different than you'd score normal math tests. And I'll show you how they would score it. All right, so in this first step, did you multiply by x times x plus 2 right there? Good. Then I'd multiply by x times x plus 2 right there. And then I multiply by x times x plus 2 right there. And then this cancels this, and I have x times x makes x squared. That cancels that, and then I have x times the 3 times the x and the 3 times the 2 would be 3x plus 6. And then I have that times that and that times, wait, no, don't do that. Why not? Cancels. All of this cancels all of that. Now I just have 4. And now I can put that to the other side, bring this 4 over here, and say x squared plus 3x. I'm subtracting 4 now, so it'll be plus 2 equals 0. And then, what can I do with that? I can factor it. Now, what if I didn't notice that it would factor? What else would always work? Quadratic form. 2, 1. And then I just double check that. Outside and the inside make 3x. Last make it 2. First make an x squared. Yep, I've double checked it. So now, what's the answer? Well, if I go x equals -2 and x equals -1, got my two answers. But here's the important part. You then have to go back up to the original problem and say, would any of those answers cause a problem? You remember this part? You remember tests where there was something and the answers wouldn't work actually when you put them back in? It happens a lot on these guys. So do you get, we got an answer of -2, and do you get that when I put a -2 right there, that would cause a problem? And so that's an extraneous answer. Oink, all that work to get an answer that didn't work. A lot of your problems are have extraneous today. Okay, so not only do you have a ton of steps to get to the quadratic, then you got to solve a quadratic, and then sometimes they don't factor nice like this. You got to use a quadratic formula. Then you get your answer. Then sometimes one of the two parts of the answer doesn't even work. Is it possible that neither answer could work? Yeah. If both answers fail, both answers crash your original problem, then you just have no answer. And you say the answer is no solutions. Yes. How do you know which side to make 0? That's a good question. So when I had this right here, you had to make a choice. And whenever you have a choice here, and you will have these today, so that's a really good question, you have to decide to either put everything over to this side or bring everything over to that side. Always do it to the side so that your lead coefficient can be positive. All right? So in other words, if I did move this over to the other side, you get how it would turn into a -x squared. And that's not good. Whenever you're factoring something that's like this, that's way harder when the lead term is negative. Because what are you going to do with factoring? You're going to try to make it -2x and x. It gets really confusing. Okay, so you don't want that lead term to be negative. So if I had one that was down to, let's say this, 4x plus 3 minus 2x equals -x squared plus 8. Which side should I put everything on? The left or the right? Put everything on the left, because that way this will become my lead term, because it's the biggest degree, and it'll be positive. So then I bring that over here, and I can say positive x squared at the beginning. And how do I get rid of the 8? Subtract an 8, so I can put in a -8 at the end here, and the whole thing will equal 0. Then I'd have x squared plus 4x. Oh, the 4x and the -2x are going to make plus 2x. And then this 3 and this -8 make -5. And then you'd hope it would factor. And let me think, this one would not factor, I don't think. 5 and 1. Yeah, you can't make a 2 out of that. So if it doesn't factor, then what do? Quadratic formula. And I would always start with the b squared minus 4ac part, and that'll tell you whether or not you proved that it really would have factored. B squared is 4 minus 4 times a times c, and the a is 1 and c is -5. And I see if that comes out to something nice. And 5 times 4 makes 20, and it's positive 20 plus 4 is 24. 24 a nice square root? No. So therefore it would never have factored. So I was right. So then I go x equals -b. That's b. Plus or minus the square root of all that stuff I already did, all over 2 times 1 is 2. Okay? Alright. So there is a typical, oh wait, that one has to be simplified more too, that's kind of a pain. That we'd have to figure out is root 6 and root 4, which would be 2 root 4, so it's -2 plus or minus 2, root 4 all over 2, and then the 2's can cancel, but they don't just disappear. What do they turn into? 1's. Then this becomes -1 plus or minus 1 root 4, which is root 4, which is, wait a minute, it's not root 4, it's root 6, sorry, all over 1, but over 1 doesn't really do anything, so there is my final answer. Now, this guy's kind of a pain. We won't make you check and see if these crash it or not, because how are you really supposed to know whether that, when you put it back in the original problem, would crash it? They're kind of a pain. So yours are going to come out to usually nice numbers today. In your nice numbers, you go back and check. And a lot of times, one of the two crashes the function. All right, so now this is the part where I'm going to give you the worksheet, but this has a big but. Don't try to do it on this worksheet, because even though there is space, there's not enough space. These are those impressive kind of problems that can take an entire page to do. Okay, so you do not have to recopy the original problem. In fact, if you want, a really efficient use of the space would be you do the first step right on this equation, and then once you get it simplified down, Then you go over to the other piece of paper and write it from there, and it still is going to take you a lot of lines, and it won't be enough room in here. So maybe on the worksheet, you just do your first step, and then you switch over to the piece of paper where you'll have plenty of room, okay? And this is just for you. I'm just trying to make sure you understand. Space is good. Having a lot of space to write in makes you much less likely to screw up. Having to scrunch your work down, it's really hard. You know, I was talking about those AP tests and how they grade them. They give you a whole page to do each problem. And so if you have a problem like this, for instance, that goes all the way down the page, okay, then they're going to give you a point for getting this far. Then they're going to give you another point for simplifying it down to here. Then they're going to give you another point for simplifying it to here, getting it setting equal to 0. Then they're going to give you another point for factoring it. Then if you screw up right there, you've at least got a bunch of points. They have a total of 9 points for each problem. So if you're one of those kids that's like, but I get the answers, I just do it in my head, you won't get much points for that. In fact, specifically, if all you have is the right answer and no work to support it, you get 1 point out of 9. There's 9 points along the way. They decide what their little parts are that they're looking for. And if you do that part, you get the point. Get another good simplification or whatever, you get a point. And you get all these points, and then the final answer is worth 1 point. All the steps up to there are 1 point each. You know what I'm saying? So there's like 9 steps to a problem. You get 1 point for each one you do right. And yes, that's different than how we grade. And that is one thing you kind of got to get used to. We're a little harsher in that you have to get to all the steps right, and then you get the point. But on the one hand, it's more harsh. But on the other hand, it's more generous in that you can get 3 out of 4 right and still get an A, right? When you get to calc, because they give you points for your work, if you get 3 out of 4 right, it's only a C. 3 out of 4 is 75%, you get a C. Okay, so you got to get used to the difference there. We're harsh about having to show every single step right to be able to, you screw up once in there, you're not going to get the point. But 3 out of 4 is an A. So you got to understand there's a difference right up front. I hope you don't use that to try to complain to the calc teachers. But we got 3 out of 4 right and we get an A. Well, that's kind of true, but we also were really harsh about any little mistake. And they're very generous with any little mistake. We don't take off the whole point. They just take off a little. So get used to showing your work. Today's a good example of needing to show your work. Okay, so here they come. Before I forget, I want you all to cross off problem 7 on this worksheet because you cannot do it without a calculator. It's a cubic, and you can't solve cubics with quadratic formula, right? And therefore, it has to be solved with a graphing calculator, and therefore we are going to skip number 7. Okay? Now let's go look at, and just for a second, look at number 8 with me. It's totally different than the other kind, and I don't want you to be confused when you get home. Number 8. It's got a picture. Looks kind of like this. And it's asking you, here's 2 possible answers. X equals -5 or X equals -2. Which one of these? It says that the 2 solutions are listed. Decide which one is extraneous, like doesn't work. Remember how we were saying if you plug the number back in and it doesn't actually work? One of these 2 doesn't work. Look at it quick. Number 8. Which one works? -5 works because it touches at the root. Remember the roots over the x-intercept? It touches right at -5 right there. And the -2, it doesn't touch there, does it? Therefore, this one is extraneous. The one that touches is the one that works. And it touches at this one, and it does not touch at that one. That's what they're trying to do, is make you think about extraneous answers in the form of a picture. Okay? All right, so that's how those work. Now flip back over to number 1, and let's do that together. You don't have to write the original problem down because it's already there. I do. So give me just a second. You formulate a plan for what you think we should do to it. All right. Do you agree we got to multiply by this and this? All right. Now, if I were you and writing it on my paper, I would write this right on your worksheet, but I'd write it kind of small. And do you get the point here? If I'm going to multiply by x plus 5 and also by x minus 2, do you get that one of them is going to cancel just right away? If you want to go ahead and do that and get it right down to just this one, that's fine. And do you get on this one? I'm going to multiply by x plus 5 and x minus 2, and the x minus 2 is just going to cancel right away. So you might as well just write down the x plus 5. You get what I'm saying? You can write them both and show their cancel. That's fine and it's good. But if you get what's going on, do you even need to write down x plus 5 and x minus 2 there? No, because it's just going to do what? It's just going to cancel. Because if you multiply out x plus 5 and x minus 2, it will come out to x squared outside and inside plus 3x and the last minus 10. It's the same thing as that. It's just going to cancel. So after everything cancels, I got a bunch of junk. And this is where, if I were you, I would transfer it to another piece of paper because it's going to take a lot of room. And I don't like to have to squish my writing down. So I would go to a separate sheet of paper and write this part up. 3x times the x makes 3x squared. 3x times the negative 2 makes minus 6x. 1 times the x plus 5 just makes x plus 5. Equals. And everything canceled over there, so it's just a 7. Well, that's not that bad. And from there, I'm going to probably just move the 7 over to this side and simplify some stuff. Do you get that the negative 6 and the positive x can go together and make negative 5x? So I'm going to have 3x squared minus 5x. And then this 7, when it comes over, is going to be negative 7. Negative 7 plus the 5 makes negative 2. And now, can I factor it or not? I don't know. So I'm going to do the hybrid thing. B squared minus 4ac. And then I'm halfway done with the quadratic formula. So b squared is 25 minus 4 times a. A is times c. And then I think about that for a minute and say, okay, I got 2 negatives. That means I'm going to really add here. So it's 25 plus 4 times 3 is 12. 12 times 2 is 24. And that makes 49. And ooh, what does that tell me? It would have factored. Now, if you want to go back and factor it, go ahead. But frankly, I think it's just about as easy. We're already halfway done with the quadratic formula. I might as well just finish the quadratic formula. And what is that again? It's x equals negative b, which would be 5, plus or minus the square root. And I already did the whole square root thing. It's 49. All over 2a. 2 times 3 makes 6. And this is why I said to put on a separate sheet of paper, because we're still going. And now we go x equals 5 plus or minus 7 over 6. And then that means I've got to do 5 plus 7 over 6. And 5 minus 7 over 6. And that's 2 answers. 5 plus 7 is 12 over 6. And that's equal to 2. And 5 minus 7 is negative 2 over 6. And that reduces to negative 1/3. There's my 2 answers at long last. But wait, there's more. Then you got to check, does one of them crash my function? Go back to the original function. Do you see how 2 would cause a problem right there? Therefore, 2 is out. Do I really have to actually plug in negative 1/3? No, that would take you forever. But you can check quick to make sure it won't crash anything. If I put a negative 1/3 there, it doesn't crash. If I put a negative 1/3 there, it doesn't crash. And since this is made up of the other 2, I've already checked it by default. So I just check these 2. And if it doesn't crash those 2, I'm good. So my answer must be x equals negative 1/3. You see how long that is? All right, so if you can write legibly and do it all on the worksheet, that's fine. But I encourage you, if it were me, I'd want to do it on a separate sheet of paper. But if you're writing clean and neatly, you can do it on the worksheet. Okay, so I want to give you a bunch of time to work, which would pretty much mean now I'm going to give you half an hour straight of work time. So please use it. I'm doing this so that you can have time to work one-on-one with me. And I don't want you to just fart around with this time. Question first, yes. Sure. if you think about it, there's x minus 3 over x, and the other one is an x plus 1, and that happens to be, if you multiplied them both together, try multiplying x times x plus 1 and see what you actually get. What do you get? X times x makes x squared, plus x times 1 makes x. Isn't that the exact same thing as the other one? Aha. So that means that we can just multiply by that. We don't have to make up a third thing, x squared plus x, because that is the other one. That's these guys multiplied together. So, final answer, what do I multiply by on everything? It's these two guys. That times that on everything. X times x plus 1. X times x plus 1. And x times x plus 1. But multiplying by 0, wouldn't that make it 0? So you can just say 0. So, this will cancel this. And I got to multiply out a quadratic here. Yay. This times this, that's just 3x. That's easy. And this will cancel this. So that's just 3. So I got to do x plus 1 times x minus 3. And then minus 3 times x makes 3x. Plus 3 equals 0. So once I get this all multiplied out, I can add some like terms together. It'll be a quadratic. From there, you're going to get a couple answers. Once you finally get your quadratic formula done and you got a couple answers, one of them probably crashes the function and is therefore extraneous. Okay, so they got a lot of steps, but you only have 6 problems to do. And I already did the first one, and I already started the second one. Okay, so get to work. If you need help, please come up and ask me. I'll put on some music and we'll just enjoy a relaxing Friday afternoon.